Okay, and then we are online. Hello again to another session of Ask the Expert. Today we even have a sponsor, which is surprisingly ZK. So last time we introduced the WCHG features, and we have some kind of how to call it, feedback survey, where you can give some feedback if you already had a chance to test it. And we have some gifts, for example, like this cap with a ZK logo on it. It's also existing in white, and some other stickers and pencils as indicated by this link. Just click it quickly and you will end up on this page. Now, on this block, there's a survey you can click and start if you like. So, advertisement finished. So we're happy for any feedback. So I think it's an important feature, and try to help us if you can, if you have any insight on something we missed in this area. Okay, today our topic is single sign-on with ZK, the related problems, the general idea how to deal with single sign-on, most likely the failures of authentication failures, and the problems that appear in an Ajax application such as ZK. Try to outline the ideal solution, and of course the workaround if the ideal solution can't be applied, which is in my experience 90% of the case, because of course I'm at the support end, so we receive the cases when the default doesn't work. So that's why we thought we cover this today. Also because it fits with our ZK 9.5, where we have a new feature that makes these workarounds easier to apply. Yeah, my name is Robert, as always, support engineer at ZK, and yeah, let's just dive into it. So single sign-on, in short SSO, is I think most of you will already know what this means. It's like the Google login, where you have a single place where you sign in, and the application you're using are just somehow using the same single sign-on session to identify the user, and in some cases also to authorize permissions based on the server capabilities, depending on what the single sign-on server offers. But here it's mostly about authentication, because that's the simplest case, just to see if a user is logged in or not, and to verify who you are. And at some point, this authentication will fail, or the authentication is not yet existing, or it times out, and then we need to interact with our application. And to illustrate this, I just picked the single sign-on server solution that I personally used in the past, so that's why I just picked it. I know it still works, and just outline the general flow. It looks more complicated than it is here, but these steps are very common for different single sign-on implementations or server integrations. In this case, we have our browser, which the user is using. Now, this is the client. Let's call it browser, because we have the protected app and the single sign-on server. And the protected app will somehow act as the client for the single sign-on server as well, because it needs to connect in the background. So what we do is we go to our application. The protected app or application figures out the user is not authenticated yet, so it will redirect it will respond with a redirection link, and in most cases to the login page. The single sign-on server will figure out whether the user is already logged in or not. If he's not logged in yet, it will present the login form. If he's already logged in, the login form is often skipped and just an authentication token is returned. The user has then a chance to log in, and if the login was successful, or as mentioned before, if this login was previously successful, the user will be redirected back to the application. Then that's not part of today. That's how the single sign-on works. In the background, there will be this kind of ticket parameter that you get from the single sign-on server, and with this ticket, you can validate with a direct connection between your application and the single sign-on server. You can verify that the ticket is valid. You can get some session information, for example, which user is currently logged in based on this ticket, and then you get some kind of session token that you can either use to revalidate that the user is still logged in, or in some cases also to extend the session to get somehow some kind of extension ticket. Not the topic today. The problem, or not the problem. Yeah, the challenge in an Ajax application like ZK is what happens when this is not a page request, but an Ajax request instead. And this is a case where ZK has several. I don't know, ZK is not having problems. It's not expecting this kind of redirect, and the HTTP implementations in browsers and the HTTP protocol itself don't make it easy to access the relevant information in these cases. That's why we need these workarounds. So here you see the positive case. Here we go to our application, we figure out the session cookie is still valid, and the application just returns. So this will be happening 99.9% of the time, and sometimes you will be redirected to a login. This one is also talking about second application, but we talk about one ZK application right now. So this is what CAS is, CAS, I don't even know what it stands for. CAS, something. So that's what this single sign-on server is doing. I had another question this morning about whether or not we can cover ADFS, and in general, I will not cover any specific single sign-on server today because I'm now I don't need any specific implementation to illustrate the problem, to reproduce the issue, and that's why I decided to use a single sign-on mock, which will just produce the error, and where we can easily put breakpoints and debug what's going on, and where requests are going and where they are received, just to demonstrate that this is independent of a single sign-on solution. Now with ADFS, if we just look into the diagrams, they have a huge amount of documentation. I found this old, it's quite old article, but they have a similar thing where you connect to an application and you're eventually redirected to a login server. You log in and then you post back to your application with a ticket, and then something will happen in the background between the application server who is aware of the ADFS something server. But not the topic today. I hope this is what you meant when you mentioned ADFS, because ADFS itself has such a huge documentation and many usage scenarios, so that this one is the one I cover today. And if there's something else, we need to find out what the problem is, or if there is a specific problem. But I'm not planning to implement, or today I can't implement or integrate the different server solutions. Okay, let's just check what else we have. So the problem with maybe I start with the easy part, the normal case when you just request a Zool page, an entry point of your application. Redirects will just work fine. Redirects will tell the browser load another page. The other page will have the login details, and it will redirect you back. And well, that's something I'm, for example, doing here. I'm starting my local application 8080, I think it's called ZK app. It's just my protected app. It will redirect to my single sign-on server. I will somehow successfully log in. I didn't care about who's logged in or what. I just have a OK button, which means login was successful. And the application will return back to, or the link will redirect back into my application. And as soon as I'm here, this one is just an HTML page, but the same works with the Zool page. As soon as I'm logged in, the page can be presented. If we log out from our SSO 1990, we just do logout. And our session is suddenly invalid, and I redirect this, reload this page. It will redirect me again to the login page. I will log in successfully. I get back to my application. I'm logged in. So this is the simple flow that everyone, I think, that everyone would be happy with if this was all, and then everyone is fine and things are working. The problems are Ajax and redirects. As soon as an Ajax request is involved, there are certain restrictions about which response codes you can actually see inside your JavaScript code because of security reasons. The redirects are made transparent to the JavaScript engine. So you can't just say status code is, or you can say status code 200, okay, or you can get any kind of error code, 404 not found, or 401 not authorized, but you can't see a 302 redirect. It will just transparently load the login page, and then the problem is that ZK does not expect an HTML page to be responded when it speaks to its Ajax engine, which returns a JSON-like syntax. And then you get parsing errors in the response, and ZK engine, the client engine, throws up errors and stops and doesn't work anymore. So that's the unfortunate problem that many people are running into, and that's why we put up this meeting to just figure out how we can help with this. I was kind of delaying this meeting because I was hoping for a better solution, but as I will, I was just disappointed by the spec. It was promising, or it sounded promising, and when we finally had the feature, I figured out it doesn't do what I expected. So I should have looked first. So my apologies for this. I don't have a nice solution, but we have a nicer way to implement the workaround. In addition to all Ajax requests, there's always cross-origin problems. There's a link if you want to read about these things, and you should, how to enable cross-origin between your single sign-on server and your ZK application. This is something you need to look into or have control about. If you can't fix CORS issues, then we can't do anything, because then the browser will just block everything you want to access from the response. And the ZK specific symptoms are already mentioned. The Ajax response will get parsing errors. I think I can demonstrate this in a second. Now, when we get into the code, so as mentioned, ZK will get parsing errors because the response is in a different format than expected. In most cases, you will lose user input because maybe the session gets invalidated at server side, or the desktops get removed because pages are reloaded, and then suddenly, users are unhappy. And the opposite would be, you could have some temporary memory leaks depending on your session timeout if the remove desktop requests are blocked because of a single sign-on session timeout. And then suddenly the desktop cannot be removed anymore from the session, and it stays there until it's rolling over, or until the session times out. I'm sorry, somehow I was eating the wrong thing before meeting. Okay, so these are problems, and we will deal with all three of these today. So then fetch spec. So what is new in ZK 9.5 is we use the fetch API instead of the previous or the legacy XML HTTP request, the XHR, just to have a better API to customize the call, to do something before, after it, and which I thought to have a way to handle redirects. And that's what the MDN says, my favorite resource of web-related issues or documentation. And it says there is a way to handle redirects manually. Unfortunately, that isn't true, or it doesn't do what it says. Instead, instead what it does is, and this is kind of cryptic, the where is the manual redirect mode here? The manual redirect mode retrieves an opaque redirect filtered response when a request is met with a redirect to allow service worker to replay the redirect offline. So it's, I don't know why they call it manually. It's just something completely different. We don't have a service worker here, so this is completely useless to us. The response is otherwise indistinguishable from a network error, which is quite disappointing. If you want to handle redirects and you just get an error and you can't even, or by definition, you are not allowed to know that this one was a redirect. So it's quite poor what they support here. I'm really disappointed, but they have their reasons. Yeah, they need this transparency for security reasons. Of course, there's always someone exploiting these features if they're useful, and then they get removed. I just found that even the author of the spec is not happy about this. I posted a correction request, so they update the documentation in the MDN. Unfortunately, it didn't get a high priority, just for fun. It gives a low priority. So that was me. I posted a request for MDN to update the docs, but they didn't yet. So it's really hard to find this. So anyway, right now we don't have something nice. They even admit that their naming is a bit misleading. And one hope for the future is that there is an opt-out way to maybe get the chance to deal with redirects manually at the extended complexity of course handling. So maybe there is something at some point. Okay, let's go deeper into the example. Or any questions so far? Is the single sign-on flow clear, or maybe just look at it in the browser directly in the network tab? So if we just, I will just log out once again from my single sign-on, and I will clear the logs and reload the page. So what we see here, I was trying to access my Zool file. Because I wasn't logged in, I was redirected to my login page. I log in. Oh, I need to preserve logs. Sorry, again, log out, reload, clear, and okay, so I get redirected. I say log in, and then I get again redirected to my main page with a with my authentication token. With my handle redirects Zool page, you see the token in the URL. This could also be a header. It depends on your implementation where the information is. In my mock implementation, I tried to make it visible so we can debug it. And then I redirect to the page itself just to avoid having the token in the URL in my page. And then ZK can access the token and is outputting it on the console. And then we can just normally work on our page. We do our application logic. We display that some data has arrived at the server side. We get our Ajax requests, and we get our requests, which was a button click in the change events, and we get a response, which will update some, in this case, update notification, or it might update your structure, navigate somewhere inside your application, all these kind of things. What we can also do now is reload the page via via client-side link, or we can issue an Ajax link and redirect via a server-side redirect response. Somehow it didn't print the response. Maybe we try again. Reload. Somehow Chrome doesn't like to output the response today. But this one, the response would contain the redirection. And as long as I'm logged in, everything is good. But at some point, the token will become invalid or maybe times out, and the server decides we want to revalidate the token. So I just invalidate the access token. I don't log out from globally. I just say my token was valid until now. So this means now my authentication token is invalidated. This one is just an iframe, which is independent of the website. It just displays the response I get from the single sign-out server. Normally, this might happen on a different page in a different browser tab, or it maybe even happens on a different computer where you single sign out, or where you say revoke all my access tokens, all these kind of things. And then I'm trying to, well, I'm continuing to work, and I want to submit my form. And in the past, ZK would then fail because the response, because now it's sending an ZK-AU, an Ajax request, which should be here, which needs to be this kind of Ajax response. So if I submit a button, if I click a button, I will now see a whole different sequence of what happens. So what we have is headers, because I said invalidate. I logged out. I invalidated my token. I sent my click event to the server. And because the token was invalid, I got redirected. And in the past, this was a problem. But now I have this redirect handler at client side that will try to capture this information and redirect to the login page, but in a different it will redirect to the login of the single sign-on server, and because the response is successful, it will just return a new token, and then I can replay my Ajax request. So my click event and my onChange events, the exact same request is just duplicated after this, and it continues to work because in the meantime the login was, or the relogin, or the revalidation of, or how to say, the recreation of a new access token was successful because I was still logged in on the single sign-on server. Yeah. So this is now the good flow. So how does this work, and how do we get this to break? And what else can we do? What we also can demonstrate is if I, for example, if I log out from SSO, from single sign-on globally, that means I now have to relog in again. So I can handle, for example, I want to change my name and submit again. Now I need to react. I need to present the user with a way to relog in. For example, in an iframe inside a pop-up window or in a new browser tab. Let the user log in, and once the user is logged in, I can replay the previous request, and my updated name appeared or was resent to the server, and it worked again. This also works in multiple browser tabs. Just to see how I do this, if I open the same thing again in a different tab. So here I am Rob 1, and here I'm Robert 2. In the meantime, my access token has become invalid. I submit this browser, I submit this browser. They both are stuck in the, now I want to, no, because because I was still logged in on the single sign-on server, of course everything succeeded. I want to log out globally, so this one will get stuck and this browser gets stuck. So now I have two login frames, and if I log in one, the other one can automatically also close and replay the request. So that's the part I'm currently demonstrating today. So let's now dig into the code. I know this will be a bit dry now, but just to give you a quick rundown of what my SSO mock is doing. So my single sign-on mock is something you don't use in production. Definitely not. This is just the simulation of the redirects and the authentication or the token generation. And of course, my tokens are just a sequence of numbers, so nothing is secure about it. It's just easier to track. So this is my mock, only my single sign-on mock, only 45 lines of codes. The only thing it has is a map of the current session tokens and a map of the currently valid access tokens. So I can have multiple applications signed in with the same single sign-on session. And there's my token sequence, just an incrementing identifier. And then there's a check to be, is someone logged in? It's just checking if the session token is available in the map. If not, there's no session available. Get access token is to get a new access token based on a session. So if the session is currently valid, it can issue a new access token, which can then be verified in the background. So it will put an access token to the current session. And there's a validate method that will check if the current. Hello? Yes, you have a question? Okay, then please, if you don't have a question, please mute yourself. Okay, I muted you. Sorry. Okay, so there are these things that you can invalidate an access token to remove it from the map, and you can log out, which will remove the session token and all the associated access tokens. And then there is the servlet, which will just deal with the different servlet mappings. There will be a servlet path. There's a login URL to check if the user is currently logged in, and if not, it will present the login UI. Otherwise, it will just redirect with a new access token. There is a do login, which will deal with the login. In my case, it always returns OK and returns an access token. There's a validation request, which can be used by the application server to directly access the single sign-on server to validate something, to validate the tokens, not via the browser. So there is some kind of secret, so that some secrets can be shared. And invalidation and logout are just the equivalent things. There's nothing fancy here. I just render static HTML, no JSPs, no ZK. So really just a mock. And for the course topics, I add some course headers. I just allow everything and every header, just to get this thing simple. In real life, this will be more complicated, but it's not a ZK problem here. In this case, it's a general security feature. So this is the mock. It will just keep track of the sessions and the access tokens. And of course, in real life, there will be the tickets, and the session tokens will be something different, and there will be maybe an extension token and multiple other things which we don't need to cover today. So this is the server side. The client side is more interesting. Still in the danger zone, so don't use this in production. All the single sign-on frameworks I've seen so far provide these kind of filters and client APIs. So this is just a mock client API that has the necessary features. And here the client API is just there to validate a token. It doesn't do anything else. The only thing you can do here is access the server directly. That's why I use the HTTP request API, HTTP API from Java 11 or Java 10. I don't remember. So I just use this API to send an HTTP request directly to the single sign-on server that does not go through the browser. And I just check the validate URL, pass in the token, which of course will never be in the URL, and in real life it will be somewhere in the headers, somewhere hidden. But here it's just to be visible, and it will get a response whether it will get what will it get? It will respond if the status code is okay. So that's the simple thing. And the filter is the more complicated part, which is then the stuff you need to customize in different frameworks. For example, in Spring has customizing hooks. In Spring, this will be a filter chain. So not just one filter, it will be a sequence of complicated filters: authentication filter, authorization filter, login filter, logout filter, whatever filter. So there will be remember me filter. So there will be lots of filters in Spring. I just put everything in one to simulate what's going on. So this filter will just check if there is an access token in the request URL. If yes, it will be stored in the current servlet session so that we know that we can revalidate the same token across different desktops. And it will redirect if there's a redirect URL. It will redirect to itself to avoid having the token in the URL in the browser. Then there are some also similar to Spring. There will be exclusions, things you want to allow to be accessed without authentication, which in my case is where's my exclusion? Excluded from authentication is my index HTML, just a static page, just some kind of landing page where you have a button to start or to log in now, and the remove desktop command, so I can clean up desktops even after a session or after a ticket becoming invalid or single sign out, and the user doesn't want to relog in again, just to be sure that ZK can clean up properly in the background. Otherwise, these things get blocked or redirected, and they don't replay again, because with a remove desktop request, you don't have this chance to replay them. Trying to keep this simple, otherwise everything else is blocked. So every resource in ZK, in this case, every Ajax request has to be authenticated. That's my scenario here. And so if I'm authenticated, I will just continue with the filtering. So either excluded, does not require authentication, or is authenticated, which means there is a valid token. The is authenticated method is here. It will use my SSO client API to validate the token, which we saw earlier. It will send the request to the server, which is not 100% efficient in real life. This will happen maybe once every 5 minutes, or depending on the token expiry date. This is implementation specific. I just do it every time to get instant feedback when a token is invalid. There may also be a reverse channel that the single sign-on server is giving you push information when single sign-on tokens time out or get invalidated. But this is features of various single sign-on servers. Okay, so if this one fails, so if it's not excluded, so it needs to be authenticated, and I'm not authenticated, I need to redirect. And that's what happens in most cases. You get redirected to the login page of the SSO server. And then you have to do something. As said, with normal pages, this works. With Ajax pages, this doesn't work. But from the Java implementation, it's all happening here. Ideally, which I would recommend, if you can do this, instead of redirection, you respond with a 403 forbidden if this was an Ajax request. Now, if this was a request to ZK-AU, then you can do normal or default error handling in ZK to deal with the login errors. As said, a 302 you can't handle. It's transparent. You will not distinguish it from any other error in the connection. But since we or assuming we can't customize it like this, it's often in larger enterprises when the single sign-on server is a server you can't touch, or it's something some bigger server implemented in a different language that somehow doesn't allow customizing or adding filters for ZK specific URLs to return, in this case with that 403 instead of a redirect 302. But if possible, this is a recommendation. If not, we have to deal with redirects, and that's what this one is. That's what this mock is simulating. So it's sending a redirect, no matter what, whether it's Ajax or page request or any kind of resource. It will just not succeed and will, unless it's a real browser request in the address bar, page request, I mean. Okay, and the rest is just boilerplate code. The application itself is then completely unaware of all this. Of course, I'm logging out a few things, doing a bit of logging on my pages, and have all these buttons that will trigger the client to log out in my iframe, just to simulate the different interactions. And what did I want to say? Yes, so so what we covered is with 302 with page request, no problem. So everything that's a Zool page can be redirected easily and you don't run into trouble. If you have Ajax requests, ideally return a 403. And if you then have a 403, you can use the existing ZK features and client-side APIs to handle errors accordingly, and then open a new browser window in the JavaScript APIs that are triggered by these configuration or method overrides you can do. Or you can override, which is now easier, you can override the ZAU fetch method, which is just the default fetch API method, just linked to the ZAU object, so it does not affect the browser's default fetch method if you override this one. So you can safely replace this method without changing the JavaScript behavior outside the ZK world of your page. If you have third-party JavaScript libraries that don't need ZK customizations, they can still use the native fetch method. If you don't have ZK 9.5 yet, you can also do something similar. You can override the XHR factory method for the Ajax requests, but just give you an idea what it looks like. It's not very nice. So you override the XHR method, and in here you can then override the open method. And when you, by overriding the open method, you can then you don't know what you have to do. You can then override the onReady state change method, and you always call the original method, and you have various options where you can add things before how you can decorate your request. For example, in this case, if you want to set a custom header, request header, for example, you can set this here. If you need to do some response handling, you can get the response text somewhere. Where was it? Send, apply, and called original function response potentially handle this. Yeah, here. So if the request returns, you can read the response text, and if this response, and then you have to do the pre-parsing for ZK. If the response text is not JSON, but something else you expect, something that starts with HTML or with a doc tab definition, then you can maybe infer that this has been a redirect to a login page, and then do something accordingly. It's tedious but possible, and we supported customers in the past doing this, but the new fetch method is much easier, available in ZK 9.5. That's why I will not go into detail right now on this one, because we're talking about the new features that make the life a bit easier, because this is just difficult. You have to handle with deal with different browser specifics, when or when not you can set headers. It would be so easy, but for example, you can only set a request header after the request had been opened once. So you have to wait for the open method to be called, and then you can call the original. You have to first call the original open method, and then the first thing you have to do is send a header into the open request. Otherwise, you can't do this. And this is much easier with the fetch API. So this is now the. So where are we on the list? So this is now the workaround, how to handle 302s. As said, we can't detect the 302 directly because it's hidden, or we can't catch the status. We have to wait for the response always, or it will just look like an error, and we will not see the redirect target. That's what it's hiding from us. So with the fetch API, it still is a lot of code, but it's doing a lot more in this case. What you do is, what you can now do is you can get an instance of the original fetch method, ZK's fetch method, and we can just redefine it. What we do is what we get is the request URI, and we get the request options. And now here we can easily add new request options. We can set headers, we can set cookies if they are allowed. We can slightly change the URL, add some parameters to the URL if the single sign-on server needs some kind of extra tokens to work correctly. So this is places where we can interact. Then we call the original fetch method, and because this one implements the promise API, we can then easily deal with responses. Now, what I already mentioned, if we have a chance to send an error code 403 forbidden, we can directly deal with the error code here and then do something with JavaScript and open the login page somewhere. Very easy. Could also be a message in the response that tells what the URL should be. So here we have an easy way of dealing with login or authentication failures. But as the workaround, instead, what we get is the request will be going to the single sign-on server, and we will get the response, which will contain the login page. Obviously, we can't display it directly, but what we get is, and this is only the final result after all the redirects that happened in the meantime, if the request was redirected, we get the response URL. If and only if the request is course is allowed to read the URL via the course headers, the cross origin policies. If they are not set correctly, you don't even get this URL. You get nothing. It's even more complicated. But if you have the if they have the course set up correctly, you can get the redirection URL, but only after the fact. Then you can do some checks with it. For example, you can check if this one starts with my global login URL, which is just a parameter in this script, and then I do my redirection. And there are multiple options you can do. I picked the easier or the simpler way. No, okay, let's just deal with it. Option one is, for example, if you decide that a failed single sign-on means the desktop should be cleaned up and the desktop is dead, you just need to, you don't want to do anything anymore. You don't want to present anything anymore. You just tell ZK the response was empty. So instead of presenting the HTML response of the login page, you just resolve the promise differently. It's some JavaScript code here. You just say empty response ZK do nothing, and then you just redirect somewhere else and you go away from the page. That's a very easy way of stopping the current user interaction. It could be a shared desktop PC where multiple users are, and if someone is for example, one person left the PC, forgot to log out, tells on his phone single sign out everywhere. Then the next user coming to the PC still maybe sees the information, tries to click a button, and then ZK decides now there was a relogin request. I just clear the page. So one option you have. Another option which I implemented is you open a new login window, in this case in an iframe, and after a successful relogin, I replay the ZK, the Ajax request. So what I do is I call my relogin method, and when the relogin succeeds, I will just call the original fetch method again with the previous URI and the previous options. So the parameters I get here, I just call again, assuming that the login was successful. And of course, if the redirect loop, it could be that the redirect completely succeeds. It goes to the single sign-on server. The single sign-on server says, everything is still okay. I respond with a token. The token is still valid, or the token is then, of course, a new token, which is valid. And then it's redirecting back to the ZKAU. Everything was transparent, so it can just work as before. So it was completely transparent. We just have a valid response even after multiple redirects. So it could be that everything was successful. So that's the decision you can do here, or you have to do with this kind of hack. You have to do something here. You have to check by the URL, or by the content of the response to infer what this was and hope it was the login page. And if something goes wrong, things go wrong. Yeah, you can't do anything. If the network is broken, you can't do. One part of the fetch API is that it will always succeed, even with HTTP error codes. So if you get an HTTP response, it will not go into the catch block. This catch block is only for real hardware or network failures or out of memory in your browser or whatever. Huh? So any other end of an HTTP connection, any other status code is a success in this case. It will result in a response object. Yeah, and then you just need to look at what the relogin is doing, and the relogin is adding or is finding a. In this case, I decided I want to display a pop-up window. I just set the position. I do model. This is all client-side JavaScript because I can't communicate with the server right now, so I just use a prepared login frame that is just hidden on this page. And inside this model window, I have an iframe, which I call SSO frame. And this iframe, I can inside this iframe, I can open the login page, which was the center component of the center login we saw in this page. So if I single sign out and I submit again, then this pop-up window will show up. I log in, request is replayed, and everything is nice. What else do I do here? So otherwise, nothing else is happening here. If the login successes, I will resolve my promise. If the login failed, I reject with an error, which we could handle somewhere here. So I encourage you to learn about promises or use async await functions if you can. So this is depending on your browser requirements. The promise API, we use a polyfill, which also works in Internet Explorer browsers, the ones we still support, so that that you can use this in ZK in general. Okay, so what else can I say? The login success. So this is just the return page, which will this is implementation I chose to do how to communicate between the different iframes. Previously, we saw I had two browser windows open with two logins, and the first of the two that succeeds will tell the other one it was successful. So I just use a quite new browser API called Broadcast Channel to easily communicate within one browser between different iframes or frames or browser tabs that all belong to the same user, to the same origin. Sorry, that belong to the same server URL. And with Broadcast Channel, it's really easy. You just post a message, and in this case, I wait 2 seconds so we can see what's happening. But you can post it immediately, and it will instantly be relogged in. So if we just do this, change this to 0, and we switch back to here, we can log out globally. We submit, we relog in, and it's instantly being replayed, my request. You see our authentication tokens change. We invalidate access token, we submit again, get a new access token. Now if I show it, it's now 21. Invalidate again, submit, and show access token 22. So it's transparently getting new access tokens as long as I'm still logged in by the on the single sign-on server. Okay. So that's what I mean by this example is this is the part you can use as an example. This is the way you can customize your client-side API. I try to provide several options here. And I hope this will cover most of the cases where redirects are involved. I know there are other solutions, maybe without redirects, or maybe where you can't use iframes or where cross origin doesn't work. There must be other details or other scenarios that maybe require something different. But the most common ones are the ones that need us to deal with redirects. And as said, the easiest thing I found is to check the redirection URL. That's the best you can get, but you can't get this URL on the first 302 response. You get this on the 200 OK response from the login page. That's something we can see here. We just clear again, and we invalidate our access token. We submit, and we see our ZKAU will always be redirected. It will be redirected to the SSO login page, and this one will happen. Now it will be redirected, and it will even call this twice. One is the course pre-flight request. If you read about course, you will find out what this means. It's just finding out if the request will be accepted. Then it's doing the real request. It will redirect again. It will come back to the login success page. And then we know that, and then we get a new token. The login success will be presented here in this iframe, and the token will be extracted by our filter implementation, and then the session is aware of the new login token, and when the login success opens, it will broadcast that the login was successful, and that's when the client side knows everything worked correctly. Okay, I assume this was tough to follow. I hope you can somehow get some information out of this, and I have a few practical links that help you maybe in your specific environment. So I want to here just go about what the code does. We already looked into this ZK implementation. Yeah, this is partially commented out. All these features we talked about, and there are some single sign-on integration APIs that provide these customizable filters. So if you can, as recommended, try to do an error code, which is easier to handle, more clean to handle. For example, in Spring Security, you have the abstract authentication processing filter and the authentication failure handler, which you can configure on this filter. And this handler it gives you access to the request and response object, and you can send an error code here if you decide that the request was an Ajax request, going to ZKAU, and then instead you can return an error. So if this is part of your application, take a chance. This will make your client-side code more clean. Right, this is documented in the Spring Security documentation somewhere. Come on, go to my link here. That's how the security filter chain goes, and you have the login failure filter here, the authentication failure handler. So that's one part of the filter chain. So that's a chance where you can implement an error code and prevent a redirection. Similar features exist in other frameworks like Apache Shiro. Has an on access denied method you can implement. If this one is on your side, it has almost the same API. How you get a servlet request, servlet response, and you can handle the response and say false to render the response directly based on your error code. So you send response, send error 403, and return false, and it will not redirect to a login page anymore in this case. So just check the API, what's available. People are asking this on the net, how to deal with these things. And the recommendation is here, return a 403 if you can. And then we can handle this at client side. Another thing is the CAS I mentioned already, the Java client docs already mentioned the same thing. So this is the link to the framework It's a bit more hidden on this page, but that's why I posted a direct link to the implementation of one specific error redirect filter. Of course, you want to have an error code, not a redirect. So you can customize this implementation, reconfigure it, and instead of sending a redirect, you can send an error to the client under the condition that your request was to ZKAU, was an Ajax request. And last but not least, I don't know, Okta is another single sign-on framework that's available. And there's also someone talking about the same thing. If we check 403, maybe we find it somewhere here on this page. 403. Oh, they don't. Maybe forbidden. Forgot which one I wanted to, where I wanted to go. Console. Protect your application using servlet login. Update the server and listener config. There's this authentication listener somewhere. Confirm authentication. Chain do filter send redirect here. So if you are following, for example, this guide and you see there's a redirect, there's always a redirect. Here's the place to decide based on the request again whether to send a redirect or an error. So most of these frameworks luckily have customizable filter chains or filters. Okay. I forgot to mention Spring. Of course, Spring Security's filter chain is very flexible. It has lots of plugins for all the popular authentication providers, maybe it Google, Facebook, Twitter, all these single sign-on, GitHub. There are APIs that just fit into the same filter chain, and then by implementing the login, the authentication failure handler, you can cover almost everything. That's why I put Spring at the top, because it's most popular and it has a common interface for these scenarios. Okay, wow, that was tough. 2 minutes for questions. Or if there's too many things, oh, there's one question already coming. Cool. I'm using something similar, but using Tomcat protection for login and not SSO, of course. The internal logic is similar, and today I've discovered that the broadcast channel that I didn't know, and I can replace my postman implementation. Very interesting. Yeah, because sometimes in ZK you could use a server push, but then a server push needs to go to the server, and if something goes wrong with the different with the server pushes, or they get blocked by the authentication chain, it's easier to communicate purely at client side. Regarding broadcast channel, be careful. It's quite new, but it's really nice. Broadcast channel, MDN, just to give you the browser support. So, not a question. Okay, so that's why I'm just covering here no IE. So this one is not for IE, but there's a fallback if you still need to communicate between windows. You can use the what is it called? Window post message. Window post message. But in this case, you have to select the window or frame, the iframe instances directly, and post messages between your iframes. But still possible, and it also has a cross-origin enabling feature. Also easy to use. Now you just say target window post message, and on the target window you say window dot listen or add listener to the message event. It looks almost the same. It's just only between single windows and not between all windows. So a fallback if you can't use broadcast channel. And then there are even more fallbacks. You can use the local storage, or you could use cookies to do this, and timers, and lots of horrible things. Broadcast channel is, I also discovered it when trying this out. So it's one of my favorite features I found here, because that's something that actually works. Okay, any other question? If not, of course, I will share the source code in the video to those of you who requested it, so you can try to run these yourself. I will add the run commands for the different servers to the meeting notes, so you won't have to find it. Or did I add them already? Wait, did I add them? No, not yet. So you don't have to figure it out yourself. I will add them. It's, I think, cd zk app. It's something as simple as maven jetty run if you don't want to run it from your IDE. Otherwise, inside the IDE, it's a configuration like this. You use a jetty runner. We've covered this in previous talks. Jetty runner, you pass in the port and whatever the port and the path of the application, and then it's running off the current module directory directly. And the same for the other one. Now, come on, let me click. Go away. Okay. The SSO mock is just another servlet application. And configure. Where's the configuration? Am I stupid? Yeah. Here. Here we have the jetty, or if you want, you can use Tomcat instead to run this locally. All you need to do is switch the Maven profile. I have two profiles. One is to include the jetty runner to run this locally, or to include the Tomcat runner to run this with the embedded Tomcat locally. And the run commands are very similar. Okay, I think that concludes it. I can only repeat our sponsor link. So give us feedback also about this session. And if you think this was too confusing, or I need to go into detail into another place, I'm always interested about to hear from you what is interesting next. Because I would like to focus on what you're interested in. Okay, then I'll stop the recording now.